Let's go over the kinetics of enzymes. We know that enzymes are biological catalysts which speed up the rate of a chemical reaction, though they are not changed. And so, what we are seeing here is simply showing us the rate of the reaction with the substrate concentration. We know that the rate of an enzyme catalyzed reaction increases as we get to increase the concentration of the substrate. Now, there will be a point in time where all the active sites of the enzyme have been already occupied by the substrate. At that point, even if we increase the amount of substrate, the rate of the reaction is not going to increase. So at that point, we say we have reached the maximum velocity, Vmax or Vm. So maximum velocity is simply a point where even when we get to increase the concentration of the substrate, there is not going to be any increase in the rate of the reaction. Now, if I get this Vm, that is the velocity, the maximum velocity, I divide it by 2. I have a middle there that is Vmax divided by 2 or half Vmax. And then I go on the graph and then drop down. What I'm going to find is Km. So this one is also going to be important. I'm going to talk about it as we go on just within a few minutes. So this is Km, the concentration of the substrate when you have got the half of the maximum velocity. So Km is simply the concentration of the substrate when we have reached half of the maximum velocity. So to determine the kinetics of the enzyme catalyzed reaction, we are going to use the Michaelis-Menten equation. Now, as we're able to see from here, this reaction is having first order kinetics, zero order kinetics. As you're able to see at this point from 0, 0 up to Vmax over 2, when I increase when I increase the substrate concentration, I'm going to increase the rate of the reaction linearly. And so that is a first order reaction. Now, as we get to go on, we see increase in substrate concentration is not affecting the rate of the reaction. So this is zero order. So we have got a combination of zero order and first order here. That is why we get to use the Michaelis-Menten equation. So what does this tell us? The initial velocity is going to be equal to the maximum velocity multiplied by the concentration of the substrate divided by Km, which is a substrate concentration at half Vmax plus the concentration of the substrate. So it's not cumbersome to know. On top, we are multiplying Vmax with the concentration of the substrate. Down, we are adding the concentration of the substrate with the concentration of the substrate at half the Vmax. So that is the Michaelis-Menten equation. Now we can also have the linear form of this equation. How do you get the linear form? Remember, we have said V initial velocity is actually given by Vmax. I can just say Vm multiplied by the concentration of the substrate divided by Km plus concentration of the substrate. So if I get to reciprocate this equation, so this is over 1, of course. I take 1 on top and then the VO comes down. We're going to have 1 over VO, and that is going to be equal to Km plus the concentration of the substrate divided by Vm plus, okay, this is not plus down, it is times the concentration of the substrate. So we have got Vm multiplied by the concentration of the substrate. Now with our mathematics, we know that we are able to split this. So we're going to have 1 over VO being equal to Km. This is going to be divided by Vm, concentration of the substrate, and then plus again the S on top divided by Vm, concentration of the substrate. The concentration of the substrate is going to distribute to both parts of the numerator. So in here, what we're going to be able to see is that this is going to be able to cancel with this, and this will give us 1 over VO, and that is going to be equal to, so we have got, what I'm going to do is I'm going to write this as Km divided by Vm, and then I'll write 1 over the concentration of S, which is basically the same thing as what we have here, and then plus 1 over Vm. Okay, so this is what we are going to end up having. So this is in the form y is equal to mx plus c, meaning I'm able to sketch a graph. The y-axis is going, if I sketch this graph, the y-axis is going to be 1 over v, and then the x-axis, this is the x-axis, we are going to have 1 over the concentration of the substrate. That is going to be a linear graph. And then what we're able to see here will give us a gradient. So if we have got a line like this one, if we find the gradient of this line, then that gradient is going to be equal to Km over Vm. And then the y-intercept C is going to be 1 over Vm, which is this point. So that is what we are able to tell from the linear form of the Michaelis-Menten equation. So basically, this is what we have. We have got 1 over velocity and then 1 over the concentration of the substrate. The slope, the gradient of the slope is giving us Km over Vmax. The y-intercept is giving us 1 over Vmax. And then we can also have this point where the graph has reached the x-axis or the x-intercept. That is going to be negative 1 over Km. Negative 1 over Km. So let's consider some practice questions. What initial reaction velocity VO is observed if substrate concentration in an enzyme reaction is 0.5 times Km and Vmax is 2.4 times 10 to the power negative 6 mole per liter per minute? So what have we been given? So we want to find VO from the question. What we've been given is concentration, substrate concentration in an enzyme reaction is, so they've given us substrate concentration and they've said it is 0.5 times Km, so that is basically 0.5 km. And then we also have Vmax, which is the maximum velocity, and that is been given as 2.4 times 10 to the power negative 6 mole per liter per minute. Okay. Now, how do we get to find VO from what we have here? We already know that VO, which is the initial velocity, is given by maximum velocity multiplied by the concentration of the substrate divided by Km plus the concentration of the substrate. So then V initial is going to be maximum velocity, that is 2.4 multiplied by 10 to the power negative 6. This one is in mole per liter minute, or mole per liter per minute. And then we are multiplying this by the concentration of the substrate. Concentration of the substrate is being given as 0.5 km. And that is going to be divided by, we have got km down. We don't know the exact value, do we? We don't know. And then plus the concentration of the substrate, which is 0.5 km. So on top, I'm going to multiply 2.4 times 10 to the power negative 6 multiplied by 0.5, and that is going to give us 1.2 times 10 to the power negative 6 km. And then we have got more per liter minute divided by, down if we add km plus 0.5 km, this is just the same as saying 1 plus 0.5. This is going to give us 1.5 km. So I see this km is going to be able to cancel with this km. And then what I'm going to say is 1.2 times 10 to the power negative 6 divided by 1.5. And that is going to give us 8 multiplied by 10 to the power negative 6, negative 7 more per liter minute. So that is going to be the answer, which is this one here. Let's consider also this one. Calculate the value of the maximum velocity for an enzyme catalyzed reaction that follows Michaelis-Menten kinetics if the initial velocity is 6 millimolar per second at a substrate concentration of 6 millimolar. The Km for the enzyme system is 2 millimolar. So what do we have? We have got the initial velocity, which is 6 millimolar per second. And then we have got the substrate concentration, which is 6 millimolar. And then we have got Km, and that is 2 millimolar. So to be able to find the maximum velocity, we know from our equation that initial velocity is equal to maximum velocity multiplied by the concentration of the substrate divided by Km plus the concentration of the substrate. So I'm going to multiply these two. So I'm going to have Vm being equal to Vo multiplied by Km plus the concentration of S. And then I'm going to divide by the concentration of S. I've made Vm the subject of the formula. Therefore, Vm is going to be Vo, that is 6. Should take note of the units. The units should be able to correlate. So this is 6 millimolar per second. And then Km is 2 plus the concentration of substrate, that is 6, divided by the concentration of the substrate, again, that is 6. So you can see, okay. So this is supposed to cancel the 6 and the 6 there. Now, let me double check my work. All right, this is okay. This 6 and this 6 is going to be able to cancel. So then Vm is going to be 8 millimolar. So that is going to be it also for this one. Let's consider this one. An enzyme that follows Michaelis-Menten kinetics as a Km. We've been given Km as 1 micromolar, and the initial velocity of the reaction, initial velocity, that is Vo, has been given as 0.1 micromolar per minute at a substrate concentration. So they've also given us the substrate concentration. Okay, the substrate concentration is been given as 100 millimolar. So what is the initial velocity when the substrate concentration is 2 millimolar? So first, let me use this data to be able to find the maximum velocity. So we know that maximum velocity from the previous that we did. Okay, let me just write it again. Initial velocity is going to be maximum velocity multiplied by the concentration of the substrate divided by Km plus the concentration of the substrate. So the maximum velocity is giving us initial velocity multiplied by Km plus the initial concentration, and then divide that by concentration of the substrate. So the maximum velocity then is going to give us initial velocity is 0.1 multiplied by Km, that is 1, plus concentration of the substrate, that is 100, and then divide that by concentration of the substrate, which is 100. 1 plus 100 is 101, multiplied by 0.1, that is going to be 10.1, and then that value we divide it by 100, we are going to get about 0.101. This is going to be the maximum velocity. It is in molar per minute. Now, what is the initial velocity when the concentration of the substrate is 2? So we've now changed this. The concentration of the substrate is no longer that value. It is now 2 millimolar. And what do we want? We want the initial. We want the initial concentration. We now know the maximum velocity. We want actually initial velocity, not concentration. So initial velocity then is going to be maximum velocity, which we are just from calculating 0.101, then multiply by the concentration of the substrate now been given 2, then divide by Km. Km is a 1 plus concentration of the substrate, that is still a 2. So I've got 0.101 multiplied by 2, and then we're going to divide. In the denominator I've got a 3, so divide by a 3. So this is giving me 0.067. So it's supposed to be in molar per second. Now, do we have such a value here? Okay, I've said this is supposed to be in molar per second, but not really molar per second because these units are in micro. So it is supposed to be in micromolar per second. Micromolar per second. Now, this is not the value. That is not the same as 0.067. That is 0.67. So if I rounded off this one, this would be 0.1 micromolar per second. So the answer I would pick is this one. Let's look at the last one here. Determine the initial rate of the enzyme M, where conditions are such that concentration of the substrate to produce half of M, maximum rate is 40 micromolar per second. If the concentration of the enzyme is 10 millimolar, determine the Kcat. Now, what does this mean? Okay, if I've got an enzyme plus the substrate, what am I going to form? The first thing that we form before we go to the product is we are going to have the enzyme to substrate complex. And then the enzyme substrate complex is now going to form the enzyme plus the product. So at this point, we have got the rate of the reaction K1, and then at this point, we have got K2. So if I'm going in the opposite direction, I'm going to have K negative 1. So when I'm talking about this kind of reaction, we have got the K2 here, we have got the K1. Now, remember we had talked about VO being equal to Vmax multiplied by the concentration of the substrate divided by Km plus the concentration of the substrate. What does this really mean? So this VO and the Km, they have got an importance. Same with the Vmax. Let me start with the importance of Km. So this Km is the concentration of the substrate when the maximum velocity is divided by 2. So the importance of Km is that it is going to, because it is telling us the concentration of the substrate when the maximum velocity is divided by 2, it is telling us the concentration of the substrate that is required for significant catalysis to occur. So that is the importance of Km. It is simply telling us the concentration of the substrate that we need to have for us to have significant catalysis happening. Another thing is that this Km is actually going to be equal to what we call the dissociation constant of the complex. Okay, the disassociation constant of the complex. Now, this Km can only be equal to the disassociation constant of the complex. That means K2. Km is going to be equal to K2. This is only if K2 is very, very, very much smaller than K negative 1. So when K2 is smaller than the rate of conversion of the substrate to the enzyme and the substrate. So when you this constant, which is here, is telling us the conversion of the enzyme substrate back to the enzyme and the substrate, meaning that we are not forming the product. So if K2 is smaller than K negative 1, this tells us that this is going to go in this way. Okay, I'm going to talk about that just a bit. Now, what does it mean if we have got a high Km? If we have got a high Km, it means that the enzyme and the substrate, they are weakly bound to each other. But if we have got a smaller Km, it means that the enzyme and the substrate are strongly held to each other. So if this value which is inside, which is K2, let's say it is 2, and then K negative 1 is 5. Okay. This means that these two are more strongly held to each other, and the enzyme is going to proceed in the forward uh, direction like that. Okay. So when K2 is very much more smaller than K negative 1, what does that tell us? That is going to tell us that Km is going to be equal to the dissociation constant of the complex. Okay. So I think I've talked about the Km, and then we want also to talk about the Vm, which is the maximum velocity. What is the significance of the maximum velocity? Now the maximum velocity Vm is just going to reveal the 10 over number of enzymes. What does that mean if we are saying 10 over number of enzymes? It is just telling us the number of substrates converted into product by an enzyme in a unit time when enzyme is attached to the substrate. So how many substrates are we converting to products? So that is the 10 over number, and that is Vmax, or the maximum velocity. So this maximum velocity is going to be equal to K2, or is going to be equal to what we call Kcat when we reach what is called equilibrium. So Vmax is going to be equal to K2 at equilibrium. So basically what we've been given here is the same as this question that we have here now needed us to understand or to have a bit of that knowledge to be able to answer it. Okay, so now let's go on and answer this question. Now we know that already initial velocity is given by maximum velocity multiplied by the concentration of the substrate, and then divide that by Km, and then plus the concentration of the substrate. But from what we've been given is that determine the initial rate of the enzyme M, where conditions are such that the concentration of the substrate to produce half of M's maximum rate. Okay, the concentration of the substrate to produce half of M's maximum rate. So what do we have? The concentration of the substrate to produce half of maximum, what do we call that? That is called Km. Okay, so we've actually been given the Km in this case. So the concentration of the substrate to produce maximum, that has been, half the maximum of M, it has been given as 40 micromolar per second. 40 micromolar per second. Okay. So basically what we've been told is we already know that Km is half of Vmax. All right. Now again, okay, this is the second part of the question. This question has got two parts. Now let's start with the first part that we've been given. Let me write like this. We know that Km is the concentration at half the maximum velocity. Now, how is this really? Well, we know that VO is equal to Vm concentration of substrate divided by the Km plus concentration of the substrate. Okay. Now again, so VO is going to be able to give us Vm multiplied by the concentration of the substrate divided by. We want now to talk about Km. From what we've been given in this question, we already know that maximum velocity is equal to, maybe we need to know this, that maximum velocity is equal to the concentration of the enzyme multiplied by K cat, because we're talking about at equilibrium. So maximum velocity is given by the concentration of the enzyme multiplied by the K2, which is also called K cat. So from this one, we are also able to determine Okay, let me end at that point. So we're saying Vmax is equal to concentration of E and then K cat. Now we come this side. We've already seen that Km is equal to the concentration of the substrate in this question. What is Km? The concentration of the substrate when you have got half of the maximum rate. And for this question, we've already been told that where conditions are such that concentration of the substrate to produce half of the maximum rate is that. So we already know Km, which is equal to S, the concentration of the substrate, meaning that Km is equal to S. And then I'm going to substitute down here where there's Km, I'm going to put S because they are equal in this question. So V initial is going to be equal to Vmax multiplied by the concentration of the substrate divided by S plus S, that is going to be 2S. So this is going to cancel with this. We are going to have V initial being equal to Vmax divided by 2, which is basically this condition which we already wrote here. So the initial concentration is going to be equal to maximum concentration divided by 2, as long as you are talking about what? You are talking about the concentration of the substrate where it is half of the maximum rate. Okay, now we already know Vmax. What is Vmax? Vmax has already been given in the question as 40 micromolar per second, and then we're going to divide that by 2, and that is going to give us the initial, which is 20 millimolar per second. So I was just trying to determine this thing which is already here. Otherwise, from the question we've already been taught. So every time we are talking about at Km, concentration of the substrate, where the concentration is equal to, if you draw just a graph, okay, we draw the graph like that, you have got maximum velocity. Now at half the maximum velocity, this value here is what we call Km. Now at this point, at Km, always initial velocity is going to be equal to maximum velocity divided by 2. We are able to determine that. Now the second part of the question says if the concentration of the enzyme is 10 millimolar, determine Kcat. Now we want to determine Kcat. Okay. Now for that one, that is where we are able to use this other equation which I wrote this side. So then to find Kcat, we are saying Vmax is going to be equal to concentration of the enzyme multiplied by Kcat. So meaning Kcat, which is also K2, is going to be equal to Vm divided by the concentration of the enzyme. And this is going to give us Vmax. I think the question has already given us that to be 40 micromolar per second. Then the concentration of the enzyme, we've been told that is 10 millimolar. Now, this is a milli, this is a micro. Those two units don't correlate, so we need to convert them to the same unit. So for the 10 millimolar, I'm going to multiply. So I can first convert to molar and then to micro if I want. Because I've got a millimolar on top, I'm going to put a millimolar down and then a molar on top. We know that a molar is bigger than a milli, and milli, in this case, we're going to say 10 to the power 3. So this will cancel with this, and then again multiply. I've got a molar on top, I'm going to put a molar down and then a micromolar on top. Molar is bigger than micro, so I'll put 1 here, and then to the micro I'll put 10 to the power negative to the power 6. As long as I put 1 in front of the bigger number, the power should always be positive, so the molar will cancel with the molar. So this 3 will cancel with the 3 there, okay. And then what we are going to remain with is only 10. So this is 10 times 10 to the power positive 3. So that is what is going to give us 10 times 10 to the power positive 3, because 1 3 has cancelled with the 3 there. So in the denominator we have got 10 times 10 to the power positive 3. Then what is this going to give us? This is going to give us, if we punch, that is going to give us 40 times 10 to the power negative 4, and it will be in per second. This one also is in millimolar. So millimolar will cancel the millimolar, so the answer will remain in second to the power negative 1.